we are going to look at solving a quadratic inequality. So we're finding solutions. We want x's that we can plug in here that will make this statement true. Another way that we might say this is we're looking for a domain. So all the x values that we can plug into this, which we would get a true result. The way that we're going to attack this is we are first going to use the quadratic formula, and then I'm going to put together a little chart to help us understand what we actually need to make this true. The first thing, quadratic formula, we're going to identify our a, our b, and our c to plug in. So looking at the coefficient here, the coefficient is 1. The coefficient here is also 1. And then our c value is -6. Make sure that you have the negative connected to the 6. When we look at our standard form for a quadratic, it's with positive in here. So a squared, a times x squared, b times x, and then c, all with positive. So the negative does go with this. We're going to plug this in now. So we're going to find two x values here using the quadratic formula. And notice I added some parentheses here because of this negative being in here multiplying. I want to make sure that I keep that negative in there with that 6. And then we're just going to simplify this. All right, 24 plus 1 is going to be 25, so the square root of 25 is 5. So we're going to end up with two cases. Our first x sub 1 is going to be -1 plus 5 divided by 2. And then our second x sub 2, will be -1 minus 5 divided by 2. And then we're just going to simplify those. 5 minus 1 is 4, so 4 divided by 2, this is going to give me 2. Over here, I'm going to have -1 minus 5 is -6. So I end up with -6 divided by 2, giving me -3. These are my two x values here. I'm going to use those in my chart. Over here, I'm going to create a chart. It's going to run from -infinity, and it's going to include these two values, so -3 would be next, then +2, and then infinity on the left. So I have this. Over on this side, this is this expression right here. All right, and then I'm going to draw some lines here to divide that out. So the next thing that I want to do is I want to choose a test point from each of these intervals. So moving from left to right, going from -infinity to -3, I want to pick a number in here. Moving from -3 to 2, I want to pick a number in here. And then from 2 to infinity, I want to pick a number in there. And then I'm going to plug those in as test values. So we don't have to get too fancy with these. I'm going to pick -4 for my test value here. I'm going to go with 0 here, and I'm going to go with 3 here. Okay, if I put -4 into here, I have -4 squared plus -4 minus 6. And I want to simplify that, and really all I care about is the sign itself, not the actual value. -4 squared is going to be a +16, and that's going to be plus -4 minus 6 is -10. So if I take 16 and I subtract 10, that is going to give me 6, which is positive. I'm going to put a big plus sign there, so I know that all the values on this interval from negative infinity up to negative 3 are going to be positive numbers. Now I'm going to use zeros. Zeros are nice to use because anything with a variable drops out. So this goes to 0, this goes to 0, leaving me only negative 6. I'm going to put a big negative in there because my value is negative 6. This is saying that on the interval negative 3 to 2, all of the x's on that interval are going to give me a negative value here. And from 2 to infinity, I'm going to plug in 3 here. So I'm going to have 3 squared plus 3 minus 6 over there. And I'm going to simplify that. So that is 9 minus 3. And that's going to give me 3 positive. So I'm going to put a big positive there. Why are we doing the positives and negatives? I want to go back and look at this. If we look at this quadratic, has to be larger than 0. Well, a number that is larger than 0, always larger than 0, this number has to be a positive number. So we need all x's that we can plug in here that gives us a positive value. When we look back at our chart, that's going to be this section and this section, the interval from negative infinity to negative 3, and the interval from 2 to infinity. Those both gave us positives over here, and that's what we're looking for here. So we're going to write the interval negative infinity is less than x, which is less than negative 3. This is one of the intervals that will be true for this. Or we can look at this other interval, which is 2 is less than x, which is less than positive infinity over here. So all of these x's will work to make this statement true. And you can choose other random values if you would like to test this out. We essentially did a random value test over here in this chart. One thing that you might want to know is, should any of these inequality signs be underlined, meaning that it could also be equal to the values? That's an excellent question if you thought of that. By convention, we don't underline the one between the infinity and the variable on either side, whether it's negative infinity or positive infinity. That leaves us to check the negative 3 and the 2. If you look back at the original, since this is not underlined, it means that this is not allowed to go to 0. If this had been underlined, this would be allowed to go to 0, and then we could actually include these points. If I plug negative 3 into here, this is going to go to 0. Remember what we found here. These are x-intercepts. These are, when I put this into the quadratic formula, it gives me 2 x's. These are x-intercepts. The y value at those locations in the Cartesian coordinate plane will be 0. So that is going to 0. Since we don't want this to go to 0 because it's not underlined, then we are not going to underline here or here. All right, I'm going to put up one more problem and allow you to take a look at it. I'll give you some time. You can pause the video. You can go ahead and try it, and then I will do a work through and you can check your work. All right, let's take a look at this problem. As I did before, I'm going to look for my a, my b, and my c values. I'm going to plug that into the quadratic formula. A is going to be 2. It's the coefficient in front of x squared. B will be 3. It's the coefficient in front of x. And then the intercept at the end here will be 1. And we plug that into the quadratic formula. Then we go through the simplification process again. Looking at what we have going on in here with the discriminant, we have 9 minus 8. That's going to give us 1. The square root of 1 is 1. So our two x possibilities will be negative 3 plus 1 divided by 4, and our second one will be negative 3 minus 1 divided by 4. Negative 3 plus 1 is negative 2, so we get negative 2 over 4, which is a half. And then over here we'll have negative 3 minus 1 is negative 4 divided by x. This is going to be negative 1. So those are our two values. We're going to use those to put into our chart. We're going to take these numbers and put them in our chart again with negative infinity on one side, positive infinity on the other, and our original quadratic is over here to the side. We are then going to choose our test values to plug into here. So I'm going to do a negative 2 here and a negative 3/4 here and a 0 over here. Plugging in negative 2 into here. We need to make sure to add some parentheses so you don't miss a negative. All right, so we're going to have 8 minus 6 is 2, plus 1 is 3, so that is positive. Plugging in negative 3/4 into here. This gives us negative 2.125, so that's negative there. And then if we plug in 0 here, these two terms with an x drop out, and we have just the 1 left that's positive, so we have positive here. Looking back at what we're looking for, we have that the quadratic is less than or equal to the 0. If we have a number that is less than 0, we are looking for a negative number. And when we look at the interval, the only interval that we have that is negative is from negative 1 to negative a half. So we want negative 1 is less than x, which is less than negative a half. This is the interval that we're looking at. Now we need to check to see if we want these underlined or not. Looking back here, this is underlined, meaning we're allowed to have 0 here. If I plug in either one of these numbers, negative 1 or negative a half, I'll get 0 because they were the results of our quadratic formula here. So we do want to underline these to include them. So this will be the set of x's that will allow this to be true. Check to make sure that this is what you got. If this is not the set of x's that you got, go back through and check your work to see where your mistake is and go back and correct that. Cheerful calculations.